Okay, welcome to Investigation 9B. This investigation covers mid-latitude cyclones. Now, a mid-latitude cyclone might sound kind of like a hurricane or a tornado or some kind of big, scary natural disaster event, but they're actually way more common than that. And in fact, much of the rainfall and storm systems that we get here in California are actually formed by mid-latitude cyclones. So, I wanted to first introduce you to the structure of a mid-latitude cyclone, and then I'm going to talk a little bit about the movement and evolution to it. My goal is to at least give you some hints and some ideas, but not to give away the store as far as the answers to this exercise. Alright, so let's do it. So first off, the center of any mid-latitude cyclone is a low-pressure system, and hence the term cyclone. Cyclones are just centers of low pressure. Now here in the northern hemisphere, if you recall from the hand twist model, winds rotate counterclockwise and into this low pressure system. What I would like you to do is kind of similar to what I'm doing right now. I'm going to use a different color. Actually, I'll use blue. What I'd like you to do is actually draw some arrows showing you how winds would rotate around the storm system. Your arrows should look something like this. Counterclockwise and into, like so. That looks like a pretty good counterclockwise and into spiral. If you need a little bit more, you can also add some more. No harm in that. But there we go. There's our big spiral, showing air that's moving into the low pressure system. Now, where does that air come from, though? Well, let's talk about that real quick and talk a little bit about how that relates to the anatomy of the storm. Okay, first off, north of the mid-latitude cyclone, we would probably be able to argue that the air is pretty cold. Why? Because the poles are up here. So, what I'm actually going to do is I'm going to label this air up here, this big mass of air up here, as cold. Now what happens is, as the low pressure is rotating counterclockwise, this cold air is then pushed down to the south and east here on the western side of this storm. So on the western side of the storm, cold air is being advected, it's being pushed south and east from the northern part of the storm. So basically cold air is wrapping around the storm. Now on the other hand, down here, this region to the south, this is closer to the equator, and this is going to be warm air. And in fact, this region right here has warm air, being drawn up from both the Gulf of Mexico and from the desert Southwest. And so this particular region right here has a lot of warm air in it, and we actually have a name for this. This is called the warm sector. So this is called the warm sector of the storm. As you can tell, I do not have good penmanship when writing with a mouse, but that's okay, it gets the job done. So this region right here is called the warm sector. Now, what about these two black lines that I drew on this image? So these two black lines, and I want to explain them to you without giving away the store. But I'm talking about this one right here, and this one down here. Well, here's what's happening. So these are each called fronts. They're basically where one air mass is moving in and another is moving out. Along this front right here, now I'm going to switch over to my laser pointer. along this front over here, warm air is pushing in, and it's pushing cold air away. Now again, I'm not going to tell you what kind of front that is, but I kind of hope I just gave you a big hint there. On the other hand, over here, cold air is pushing in and it's pushing warm air away. So again, not going to tell you what kind of front it is, but I'm hoping that that will give you a pretty good hint. Now, because this low pressure is rotating counterclockwise, these frontal systems are also going to move. This mystery front here is going to begin moving to the north. This mystery front down here is going to begin moving to the south and east. What's interesting is that whichever one of these two is the warm front actually travels slower than the cold front. And the reason why is because warm air is less dense, hence it doesn't have as much force to it. It can't move as easily. Think about the last time you ever tried to kick a really solid, dense object with your foot. Ouch! Well, the same thing is true here. Warm air is like your foot, cold air is like that dense, solid object.